Welcome to our module on process simulation. The simulator takes your business process diagrams and creates an animation describing how those processes would behave in the real world. This animation and the output simulation report allow you to see what would happen if the business processes had actually been performed. Simulating your processes allows you to see how effective they are and to analyze the impact that changes would have on those processes without adversely impacting your actual business. When we simulate, we're dynamically modeling processes over time with an animation. It allows us to analyze, validate, and perform what-if scenarios, including breakpoints, warm-up times, and results reporting. And we utilize real metrics with statistical variances to get the best results possible. We need to review diagram rules as a precursor for simulation. So diagram rules ensure that diagrams conform to predefined standards and notation. A diagram's rules decide the following things about a diagram: which consistency rules will be available to use on the diagram, and which actions will be disabled and enabled on any diagram. For example, an event cannot connect to an application on a dynamics diagram. There are 7 different diagram rules, excluding no rules, but the main one that we're concerned about is the dynamics diagram rules. So in dynamics, the diagram is specifically designed for simulation. It's an event result process swim lane diagram with some special objects such as connector sets, iteration groups, and process breaks. It's often used in conjunction with diagram categories to describe decomposition levels of process flows, but primarily what we're concerned about is the fact that if you were to create a diagram that is not consistent, it's not based on dynamics diagram rules, this simulator icon, which you see on the left, would not light up. So it would be grayed out, as you can see on the right. And that is how you can tell if your diagram is not based on dynamics diagram rules, and in fact, you would need to change that in order to be able to simulate your diagram. There are different objects that are used for simulation. Events have a job frequency and growth, which we use for simulation. Processes have the most number of properties. There's service time, which is how long a process takes to execute. Minimum and maximum batch, which is the number of processes we do at any given time, plus or minus a variation. And these are all based on statistical distribution. There's a resources per batch. That's how many humans it takes to do a certain process or to do a batch of a certain process in the allotted service time. And the concurrency is the parallel processing. Now, speaking of these humans, we do have the organization's object, and that is where we determine how many resources we have available, as well as their direct and indirect cost. In addition, we also have connectors. Connectors allow us to specify a delay and a percent split. We have connector sets, which can be either independent or recombinant. We have iteration groups, which can have a number of iterations. Process breaks, which can have a delay, it's kind of like a connector, but it's a larger object on the diagram and must be restarted by an event. And then we also have results. The results do not actually have any properties that we have to put in to simulate, but they are used to capture the metrics during the simulation. Process throughput in greater detail. How long does it take to run a process? That's the service time. How many people or resources does this take, which is the number of resources per batch? Can the job be worked on concurrently by more than one resource? That's the concurrency. And can jobs be batched? If so, what are the minimum and maximum sizes that trigger or end a process? So in the minimum batch, if we set this to 1, as soon as one process arrives at this process step, allocate stock, it will go through. If we have it set to 5, then we must wait for 5 processes to arrive at the spot before we can move forward. Process cost, direct versus indirect. So each process has a cost tab, and where we can specify direct versus indirect cost. A direct cost may be something that you can directly see on the process, and indirect may be something indirect. So allocate stock, perhaps that could be something that's required by the person doing this process Perhaps it's the cost of any kind of hardware or software that's running in order to do this versus the actual direct cost for the process. The organization itself has direct and indirect cost, and the number of resources working in that organization or the number of resources available. And when you're simulating, the cost for the related resource are added to the cost for the processes in the simulation reports. You don't have to add those up manually. So if you have a process cost and a resource cost, when you simulate those, they will be added up. So you don't need to worry. To prepare a diagram for simulation, the first thing you do is click the simulator button from the tools menu. Of course, you will need to put in some metrics and then click on start. When you click on start, if there are any problems with your simulation diagram, you will see that information at the bottom in the errors and warnings section. So you need to go through the errors and warnings and make sure that they're all been validated and cleared up so you could actually run your simulation. So to run a simulation, we need to open up a diagram, check it for simulation, fix the errors, and rerun it. And you can run the simulation multiple times, changing the process metrics to actually see your different results. That's the most accurate thing to do for real-life examples. We're going to open up a diagram and take a look at simulation in the tool. Here is the Manage Unloading Process diagram. And you can see when I zoom in on this diagram, drive to control tower, for instance, is a process, and it has a 5-minute service time. Now, some of these models were created in French first, which is why it says plain instead of flat, but that is the flat distribution. So you'll notice that it says 5 minutes plus or minus 0. On the cost tab, we don't have any cost for this process. Frequency and growth is not used for simulation. Frequency and growth is populated by a child diagram. So if you were to simulate a child diagram and aggregate the results, this frequency field will be populated by that simulation and aggregation. So you need to make sure you at least have your service time for your processes. Your events must have a frequency. So here we have 20 per hour. That's how many are being delivered based on the delivery distribution. So in order to start the simulation, we click on the simulator button from the tools menu, which will launch the simulator component in a separate window. And once it opens, you can maximize the screen. You can use all of your normal functions like F4. Once you have this opened up on your screen, you can click on the validate button, which will validate the diagram. I have 0 warnings. If we had warnings, they would show up down here in the errors and warning section, and then you could go through and validate them. So I'll show you an example of that in just a moment. Now, in order to start the simulation, you click on the start button. You'll get a simulation run to choose from. This one is simulation 24 hours. If I click edit on that, I'll be able to see this is a simulation run. It is starting on Monday, January 20th, 2014. We can actually have it start today on August 6th. This is the time. You can have a warm-up time, and it is animated, and there's my animation speed. If we set it to 5.9, that's the fastest animation that you can run on. And now when I click run, it will actually run my simulation. You can adjust the numbers as you see fit. I'm going to continue this so we can watch this a little bit longer. And now let's pause. So every process has a top number and a bottom number. The top number is what's being processed. The bottom number is what's waiting in the queue. So you can actually watch the unload truck process that has a 7 in the top, 91 in the bottom. There are also 22 people are currently working in the unloading dock. So that's what that 22 means. So every swim lane has a number at the bottom. You can watch those. You can also watch the number of delivery trucks that have arrived and the number that have unloaded, etc. So you can just watch the simulation, and you can, of course, do this on your own. This is a diagram that's available in the EA Foundation sample model. It's the Manage Unloading Process diagram. And you can also click on the report button, which will create a report for you from the simulation. So when you click on that, it will ask you to give it a description, which you don't have to have, and save this on your computer. So I will save this on my desktop, Manage Unloading Process. And the simulation report will open up in Excel, and you can look at the report. The top section is all about just the details of the simulation itself. And as we scroll through, you'll see the events, the processes, and other object types in here. And the way it's organized is by object type. You can see the service times, minimum and maximum batches, concurrency, direct and indirect cost, resources, etc. And each one of these processes, you can actually see these are the process names. You can see their metrics. And as we scroll to the right, you can start to notice the arrival rate, completions, the number being processed right now. So you can see there are 10 being processed right now. And we could actually go back to the simulation and see which ones are being processed. So that's the top number, if you recall. So we have 1 invalidate access and assign unloading dock, 1 in welcome driver to unloading dock, so that's 2, 7 over here in unloading truck, and 1 in the drive out. So those are your 10. Those are the 10 that are being processed right now. You can watch those. You can also see the number of arrivals, the number of completions. So there's a difference there. So that means the 10 are being processed and the other ones are waiting in the queue. So we could, of course, see the queue from the simulation run. That's the 91 right there. Yep, that's our queue. And then as we scroll to the right, you can actually see the utilizations, average, maximum, the maximum queues. So this gives you a lot more information about your process and how it performed under these scenarios. Remember, we ran it twice. We ran it for 2 days. There was a breakpoint reached after 24 hours. We ran the simulation again, and this is where we came to after 2 days. You can also scroll to the bottom to see any other object types in here, such as iteration groups, process breaks, results, and organizations. And this will give you the cost of the resources in the organization. But if you remember, I mentioned before in the process section, we will give you the cost for the processes, which includes the resources. So as you scroll to the right, you can actually see the total cost, and that includes any total direct and indirect cost. So if you had cost here, this would all be added up in this section. And I'm going to end the simulation and close the simulator. I'm going to show you a really simple error that would happen if something was missing. I'm going to delete this connector between those 2 process steps, open up the simulator again. When I open up the simulator, I will not be able to continue that simulation without fixing that problem, the fact that I have a missing connector. So again, if we click on Start, it will give me 2 errors and 0 warnings, and it'll say the simulation is impossible. With this, the process must have an output connector, and this process must have an input connector. So if I try to start, it will tell me I can't because I have these errors. So I have to go back and re-add this connector between those 2 objects. I'll make these mandatory because it is a mandatory path between those 2. These 2 are optional, meaning it's one way or the other, and normally we would specify what % of the time we go one path or another. So this one is 10. So this one must be 90. And if they didn't add up to 100 without another pass. So here, this one is 60. I apologize, I didn't see the third one. And so with 10 plus 60 would be 70. So this guy's got to be 30. And there's our 30% split. So if these didn't add up to 100, that would be another thing the simulator engine would pick up. So now that we've put the line back in, we can click on the simulator button and validate that diagram. And now it should be ready for simulation, which would give us the same results we had before. So in order to get different results, you can always just click on the validate button. You can see there's 0 warnings, so we may start our simulation. So I'm going to close this since we have already done this. One last thing we can do is we can actually run a simulation for 2 different diagrams, one at a time, in the situation where one is an as-is process flow and one is a to-be. So you can see I've pulled those up on my screen. That's from the Irwin Framework example model. So that's another model that ships with the product. So you're welcome to check it out. There is a process order as-is diagram and a process order to-be diagram. So I've pulled up both of these diagrams. You can see the difference between the 2 is that on the left one, the first swim lane does 1 process and the third one does 3. On the second version, in the to-be version, the first one, which is sales, does 2, and the third one, which is warehouse, also does 2. So it's more of a balanced situation here. To see them a little bit better, we can, of course, zoom in a little bit more so you can actually see what the names say. And here we can see that it's sales, finance, warehouse, and transport, and then all the different activities. In this case, they're called derived logical processes. So these are the type of processes that are in this model. So in order to simulate the diagram, we simulate one at a time. So to do the simulation, we would go to the Tools menu, click Simulator, just like with any other example. Once the simulator launches, we can always run validation first. There's 0 warnings, so we can run the simulation. And let's go ahead and run that. We can always watch the clock at the bottom left screen of the diagram. So how long has this been running for? It's been running since June 19th. It's now on June 30th. We can run that indefinitely. When we run it, you can see that we ran it from June 19th to July 9th. We can always do that, or better yet, we can actually have what is called a breakpoint. And when we have a breakpoint, it makes sense to have a breakpoint for, let's say, 1 day, and we have to set the breakpoint. So if we set it for 1 day, it will be a pause in the simulation. So if our frequency on the event is 9 per working day, that means that we're going to run this for 1 day, and we should get something around that 9 plus or minus 2 values. So let's go ahead and run the simulation for that 1 day, and we'll do the same thing in the 2B. So you can see as soon as we've run it, it paused, and now we can actually look at a report and actually see what the values are. And this is our as-is diagram. We can go ahead and save it on the desktop, and then we'll have the 2B diagram, and then we can compare the results. So the as-is results are right here. And we can see the simulation ran for 1 day, and we can actually see how many things have come through. So the minimum and maximum batches as before, we can see the total number. So we can see the total number of the total service time. We can also see the total number of processes that have been processed. So we have 101 completions, 116 arrivals. So then there are some that are waiting in the queue. So some are waiting in the queue or are being processed right now. So we can see right there's 14 are waiting in the queue, and then there's the 15th one that's being processed right now. So that's the as-is diagram, and then what we'll do is we'll open up the to-be diagram once we're in it, and we can, leave them like this as tabs, or of course, just drag this tab into this middle panel and take up the full space. Now let's try that to-be diagram. Once we've run the as-is diagram simulation, we should open up the to-be diagram. We can maximize it on the screen just so you can see all the details and launch the simulator. When you launch the simulator, it will open up the simulator window once again. You can use F4 in here as well to center to the screen. You can always use the buttons right here. So fit to window, that's the same thing as your F4. And let's check our breakpoint. So we want to make sure we have the same breakpoint. So an elapsed time of 1 day. And then we'll run it. So when we ran the simulation, we can actually see the numbers down there. We can actually see we received 23, how many we've delivered. And let's go ahead and look at the report. And the best thing to do, of course, is to compare your reports side by side. Later, you can do some nice macros in Excel. Since they're both in Excel, you can actually compare. And one thing we can see is if we had more progress in the 2B diagram. So we have the totals in row 39. So now we can see we have 113 arrivals and 99 completions, which compared to the as-is, which was 116 arrivals and 101 completions. So there's actually a different number there. And you can see if one is better than the other, the total service time, the costs. So one is 166.03 for total indirect and 2,513 for total direct. And then you can, of course, compare that to the 2B, looking at all the total costs, which is 2,431 and 167.71. So this is one thing is we've saved money in the 2B from 2,500 and 166 to 2,400 and 167. So it's saving about $100 there, it looks like. So these are just some of the things you can compare when you run your simulations, and really just do a nice chart in Excel to be able to compare all of those. So we ran the simulation. I do recommend that you run this on other diagrams, even ones that were not set up in the EA Foundation model. Simply create your own simple process flow, add processes, make sure everything is connected, make sure that there's an event and a result, at least one, and that you have an event frequency and process service time. So to summarize, simulation is a great way to validate your business process flow. It allows you to see bottlenecks, check your resource utilization, and to see how a flow can be improved. Use simulation as a communication tool with all the process stakeholders. Thank you so much for your attention.